Hello. Okay. So hello, everyone. I will chair some sessions today from 1:30 to 3 p.m. So first of all, we have here Artem Kislovsky that will talk about CI/CD pipelines. He's majored in physics, if I'm right, with currently working as a software engineer. So please, Artem, stage is yours.
Yeah. Thank you. So imagine that you're a young student sitting and writing your code, and the compiler says that your bug is on line 26. But yeah, it's late at night, and it's a C program. There is no one to help. It was how I started with programming. And after I was done with that program, knowing that, okay, it's not compiling, I was also going to another guy who was supposed to work with me on some other aspect of that program. And we wanted to integrate together, like to integrate two pieces together. And it was a nightmare because it was easier to some of us just to rewrite everything because the author is right next to you. So you can integrate your changes to your code on machine and then just to take one copy of the software that works. And yeah, it was that poor student was me. It was many years ago when I just started learning programming with C language. My name is Artem Kislovsky. Currently, I am a software engineer, and I'm so happy that at my the first programming job, I was introduced to the practice which is called continuous integration and continuous delivery. It made my life way easier. I'm not afraid of the code, and actually now I'm experiencing lots of fun when doing that. So when we talk about the continuous integration, we usually assume that you should have some toolbox already in your pocket. Here I'm talking about the Git. And different authors, they love to split the continuous integration in many different steps. But in my talk, I split it into 7 steps. And usually to prevent those things to happen that I mentioned in my beginning of the talk when I don't know how to integrate the changes, you have a pretty well-defined workflow. So you start develop your code locally on your machine, then you push your code to some remote server where you can open the pull request. Then there is some magic going on by running automating test. And then if the test pass, they give you a green light to merge to the main branch. After this is done, you have another set of tests that verify that, hey, actually your package is still working and everything is fine. And after that, you produce your artifact, which is the result of running your continuous integration pipeline. And finally, you're free to distribute it along, well, with the world. And this artifact, it can be anything. So most of the cases, it's your code that you wrote, but it can be the report, or it can be something else that you generate in your continuous integration pipeline. But since we are here at EuroSciPy, I will focus more on the Py part of the project. So, and maybe step a bit aside from the continuous integration for a moment and talk about the Python packaging. Because I think before we start, well, delivering something, we need to ensure that this is something that still works and looks nice. There are lots of materials out of there. So, and I found Python documentation has very nice tutorial about packaging the projects. And after you finish with that tutorial, you have something simple as shown here. And basically at EuroSciPy directory, I define the SRC folder where I have a simple greeter project where I have 2 files, the under main method and the greeter method. I said 2 files, but in reality there are 3. The .init method is just an empty file that helps Python to tell that this is a package. And inside my very simple program, I do one of things like in main.py, we import sys and then pass any arguments we have in the command line to the greet method, and the greet method sits in the greeter.py. And why I think this is important, because usually, well, I see people struggling with packaging even, yeah, sure.
Hi.
Yeah, hello.
I have to speak on the microphone. This is standard Python or this is poetry? This looks like poetry.
No, this is the standard Python. So if you follow the Python tutorial on the Python packages with 6.1, yeah, you will end up with this structure,
Okay.
with PyProject.toml. I'll elaborate a bit more.
Okay,
but we can focus on the questions in the end. Well, why I think this is important, because many people struggle with that. And in my practice, even experienced software engineers, they don't really know how to well, import the module correctly. And usually when you write your Python program, you repeat 3 steps, and those 3 steps are, that's supposed to be the video. Yeah, and those steps are: you create a virtual environment, you source the virtual environment, and then you start running the code. But before, why I think it's very nice to package your code as a package, because it allows people use your code easily. So it increased maintainability and usability. And here, as the 3rd step, you see that I'm not calling some Python file. So I install my package, which is on the left, as an editable package. And that has some benefits, because now I can call my main.py function with hello EuroSciPy and have nice output. I can also call the directory, the Greeter project, and have the same output. I also can run this simple project as a module. And what we usually tend to do is we can freely use the greeter method inside our code. And as you can see, even if we change the directory to some other directory, but we still stay within the virtual environment, we still are able to import the greeter from the greeter project, and it still continues to work. And the nice thing about that approach is that if you need to modify your package, so you can freely say that, okay, I now want a bit different script to print my stuff on the screen. So you can edit the file and your behavior is picked up automatically. So yeah, that increased usability a lot. And I think that's the first thing that you need to have before you start distributing it. This packaging is done by new PEP 6.1. It's now, but you can find it a bit tricky, because if you go to the default setup tools, the PyProject.toml, it looks a bit scary, and I was a bit scary before because I didn't know how to actually, what fields I need for my minimal project to work. But in reality, you just need a few lines of code to define your project as a, as a package, and then you can run the commands that I just showed you and install your package as an editable package. I believe this increased usability of your code a lot. And now you're done with your awesome code. You're ready to say to the world that, hey, everyone, you're free to use my package. And you need to be very explicit in that intent. And that's what I learned from another beautiful person that I'll cite after, the licensing. So that's the way to say to the world that, hey, actually, you are free to use it. And I'm completely fine if you will. And licensing is usually meant from this, pipeline, because we usually write the code, but not focusing on the license, but it's very important. And you can see around like what other packages, and for example, I just quickly search and SciPy, they say that, okay, they are open source and they are under the liberal BSD license. The same goes to the NumPy, and basically that's the way for the world to say, hey, I really want this package to be used. And that's a nice idea to include it into your project. So if you're lost, there are like many good licenses out there. So most of the common one is MIT, Apache, or unlicensed one. There is a very nice website to choose your license. So likely you spend 5 minutes and then you're equipped for the rest of your life. If you don't want to read this website, you just can follow Anvisha Das. So she gave a beautiful keynote at PyCon Italy, and actually that was the person for whom I learned that licensing is actually very important. Really recommend it. And now we are at the step where we already have our artifact, and we are free to introduce the continuous integration pipeline. For that, we usually I usually host my code on the GitHub, and I think the natural way for having your continuous integration would be to go to the GitHub Actions. What happens? The GitHub Actions, it's a robot that listens to some events, and the number of events is huge. I linked them on the left, but the list is amazing. So you can use any trigger you want. You can even schedule the cron jobs to run some automation. GitHub Actions, they also have very liberal free tier, so I've never encountered myself some issues with that, but yeah, just for you to know, there are 2,000 minutes that you can use per month, but yeah, I think you will never exceed that in your pet projects. And that's how it looks like. And for example, you can see this is a repository for the talks I give. And you could notice that there are 3 talks I gave already this year. And for each of the talk, I tried to create a small project that I can reuse and share with you after, so you can use it as a reference project. And yeah, and in my GitHub Actions, it's just like listens for any trigger, and for that trigger, it's any commit I do. I just want to be sure that if I introduce something at EuroSciPy talk, it doesn't break my other talk materials. So, and that's how it's used in the UI. And I think what is most common here and most useful for audience here, it's to, well, to test your code on the different platforms. Because usually when I remember I was in academia, it was kind of painful because someone works on Mac, someone works on Ubuntu, someone works on Windows, and usually you share your code that's supposed to work with someone, and okay, it's not working, you have to spend lots of time debugging. But with GitHub Actions, I think now you see the benefits of having it, so you can test your code and you can see that, okay, it still works under the different versions of Python on the different operating systems. And as everything in the DevOps world, everything is defined in a YAML format. So when we start coding there, we don't actually write the code, but we write some scenarios, what and how our CI should look like. And there are, again, lots of materials out there, but usually you can identify the building blocks of that pipelines. So you give your pipeline a name, then you have another block, which is on block, where you define what would be the trigger for your workflow. And in that case of the EuroSciPy, it's a pull request, and I want to run this automation anytime I have a pull request open to the main branch, and I want to run it on any push hook. There is also a default method, but you can ignore up to now. And then you define what actually you want to do with that magic computer which is on the cloud. This is done in the jobs directive. So you can, well, GitHub recently introduced this matrix notation, so you can use different operating system or different Python versions. So it's, yeah, it basically runs your workflow on different machines, and so that's how you can be sure that your project is still working under the different operating systems. And then in the steps, just keep in mind that you have empty virtual machine, so you just need to repeat the process of setting up, like checking out the code, setting up the Python, and then everything that would you do on empty machine if you would do it from scratch. And as I was thinking before that talk, like you may find that writing YAML files is a bit tricky. Why? Because usually you write that file, and to see if it works or not, you need to make it commit, and then you need to wait for 5 minutes, and sometimes your workflow can, well, take 10 minutes before you get feedback. It's nice to have a feedback instantly, so there is a nice project called Act, written in Go, that allows you to run your GitHub Actions manually and locally. Oops, again, the problem with the video, stop. And for example, here, like I'm inside my talks repository. I have 3 workflows defined for the conference I gave this year. And then what you can do, you can just call act command, and it will show you every workflow that you have defined in that workflow directory. And since now we are at EuroSciPy, so it's somewhere here, I'll highlight it and I will run it locally. So I basically use act to build my CI pipeline, and I immediately see if my YAML is valid one, if it's working or not, or I need to fix anything. So, and usually, yeah, you see lots of steps, but the final job successful, it gives me that, okay, now your YAML file is green, you can commit your changes to your feature branch. All right, and I couldn't find the source of the phrase that I always keep in mind working with continuous integration, and the phrase is quite simple: shift your errors left. And basically that's what we are trying to do with CI/CD. And what means shift your errors left? It means that as soon as you develop any feature, you already have your context, and you would be the fastest to solve that issue if anything appears. And it's very bad if your error manifested somewhere like by third parties or someone creates a bug, because usually you don't have any context why your program is failing. So it's better to shift your errors left so that you can deal with that instantly and fix the problem. Usually there are a couple of things that you can integrate in that pipeline. So there are lots of static analyzers out there, the most popular one. So you can basically, when you shift your errors left, you split errors on the different categories. So what you could have the formatting issues, you can have linter issues, you can have some bugs. And there are tons of tools that you can easily integrate in your GitHub Actions. So the most popular is the black, it's for formatting. Flake 8 is for compliance with PEP 8. PyLint will give you some hints about what you could do in your code better. Rough is becoming very popular, and as nowadays everything is rewritten in Rust, and Rough is written in Rust, so it's becoming, how to say, the number of stars that Rough has, it's increasing drastically. And there is also a bandit that you can use to search security vulnerabilities. There are also third parties actions that you can introduce in your GitHub Actions workflow. And for example, you can use a Sonar Cloud. As you can see, it tries to find the bugs, vulnerabilities, or some security issues in your code. And it also helps you to tell that is it a well-written code or not. And each of the linter, it works as a safety net. So no one is ideal, but the more you have safety nets that ensure that the software you write is less error prone. But sometimes you have some funny situations. And for example, I have another GitHub Actions that was triggered yesterday, and it was the Git Guardian actions. And what it tells me that actually I leaked something, but it was not a key that I leaked, but it was my key presentation that I committed to the GitHub, so for you to share, and the one that I use now. But it says, hey, you have a security vulnerability because your key file is leaked. But yeah, sometimes they do funny stuff. But no one is insured. And for example, you could remember the situation from March of this year when GitHub actually exposed one of their private keys. And then if you're a GitHub user, you had to retrust to the new GitHub key of the GitHub. And you see that even the companies and giants as a GitHub keep repeating those errors. So and it's nice to use some actions that prevent you of having those troubles downstream. As I briefly mentioned, so also it's very nice to shift your error left and to separate into separate blocks. And for example, the formatting of my code has nothing to do with the testing of that code. And I don't want to run any other action that depends on the functionality of the code if this functionality is broken. So that's why it's nice to introduce some stage. So for example, if I have the problem with the linting, I see that, okay, probably I forgot to run the formatter. Or if I broke any test, so I will see immediately that the test is broken. And I will not continue to another step, which is the generate PDF report. I used it for the talk in Python Italy, if you're interested in. Another time repetition is the key. So you define your jobs in the directive format, so from top to bottom. So you check out your code, you set up Python, and then you're free to run formatter as a black or Flake 8. And usually you see that it's done by having the run attribute in the YAML file. Another thing that is very important is the testing. And I think it's kind of short presentation to give you in depth how you should test the code. But my question to Florian was like, hey, I'm giving a talk about CI and what you can recommend me to recommend people to learn more about the PyTest. And his answer was like, look into the Python testing with PyTest. And actually, that's a very good book that I can recommend that guides you how to write your test properly. That part would be covered there. Another thing is like programmers are lazy, myself included, and we always want to have our code to be as fast as possible, as best as possible. We live in the dynamic environment where, I don't know, the pandas release, the new release, the NumPy introduce some optimizations, or like any other dependency create something cool that now our code would work faster. And you can achieve this laziness by introducing some robots that will check for automatic updates. To my knowledge, I mean, there are two main ones. It's a Renovate and Dependabot from the GitHub, and Renovate is by, it's open source actually. And I found myself using the Renovate more because it's more customizable. I can tell, for example, Renovate, hey, if I have a update for pandas in my pyproject.toml, but I also have a Docker file sitting nearby, I can say Renovate to open only one PR for those two dependencies. And that's how it looks like. So usually in my talks repository, there are only two contributors. It's myself and the Renovate bot. So thank you, Renovate bot. Yeah, and it's actually quite cool because, for example, in that case, I use Renovate, and it already shows me that, OK, the pandas released a new version. We see that it's 45 days old. Only 9% people merged it. And the confidence is quite high. I think it's computed by the number of times people revert that comment. And there is also a changelog directly here. So, and I don't need to go to the GitHub repo and to see what they changed in pandas. I can quickly see, oh, wow, cool, good job, pandas. So maybe my pipelines will run faster. And actually, you can see immediately effect on the complex projects, how your pipelines become a bit faster. And coming back to the continuous integration. So I said only 7 steps that you keep in mind. And yeah, I think we can stop here. So you can find more resources, including tutorials, books, and articles that I found in web that are very useful in this GitHub repository, which is my family name in the talks. And I'm open to answer any questions if you have them. And if you're beginner and inspired by this talk but don't know where to start, I'm here all conference and I would be happy to help. Yeah, and for the advanced people, I also want to learn more about your CI pipelines and yeah, how you deal with them.
Thank you very much. So, question session. We have one question here.
Hi, hello again.
Yeah.
How about, do you know pre-commit?
Yes, so pre-commit, it helps you to run some checks before you even commit to the GitHub. So basically, if you look into this pipeline that I showed you, it exists between 1 and 2. And usually, it's a very nice tool to set up on your local environment. Yes.
It's like you can put act there, so.
Yeah, you can put, yeah, it's basically act falls into the same category of checking that everything would be green.
Yeah, it's very nice because then you have clean.
Correct.
Commits.
Yes. Because in my case, I kind of skipped talking about the pre-commit, and you see that you can still commit the key. Like, for example, in my case, it was a keynote presentation, but you could imagine that I can commit the private key from my EC2 instance or any other instance, and it would be already there, which is bad. So, but I will be immediately notified that, hey, you need to take an action, you need to revoke the key. So.
Yeah.
In my previous company, we used to have this pipeline for a CI/CD itself. Like they had some versioning tool and then some pipeline to update. But since I started working on some Python projects recently, I would like to know what are the important things that I need to look out for creating a CI/CD from the scratch for my project.
Right. So the best way, you can see how it's set up specifically for this simple project that I introduced. I think it's complete. So I didn't include the tests I mentioned, but I introduced some dummy tests, and you see how everything is wired. So you can just check out the talks in EuroSciPy. You'll see how it works, and then just look around. I think, well, you can look how CI is introduced at NumPy or at Pandas, and yeah, basically you will look into the .github repository, and then you search what they do, and you can be inspired by this open source community GitHub repos. But I also, in this repository, I linked an extensive number of tutorials and talks, so you can check them out. They're very good.
There is still time for one or two more questions if someone is willing to ask.
I'm not entirely sure what I'm talking about here, but I've seen some discussion around like CI/CD
Right.
involving like not involving pull requests as a I don't know. I saw it in like a more pure theoretical CI/CD
Right.
does not involve pull requests. Have you heard anything about that?
CI/CD as a concept it dates back it's software engineering practices. It exists before the GitHub Actions that I mentioned, and etc. So I think there is a fundamental book that dates back to 2003 called Continuous Integration, where people just at that time even Git was not so popular, but the core concept is still the same. You have to do the incremental changes to your code and to have some test suite to make the development process easier and more fun. I'm not sure I'm answered the question correctly or if I misunderstood it, so yeah. We can talk offline after. All right?
Okay, I think that's it. So one more applause for Artem. Thank you.